So it's just saying about the scale, where if you go in 3s or 6s or 9s or 7s, anything that isn't 2s, 5s, 10s or 1s, you may be penalised, and that can seem a little bit harsh. But if you do that, you're relying on being a little bit lucky. So look for a sensible scale that allows you to plot the points, and you're much less likely to make mistakes if you have sensible scales. So looking at this, we've got to plot 0, 0. It was common for people to forget to do that. Then we are looking at 0.3 volts and 0.5 milliamps. So at this point, useful to me to mark on that that's 2.5. And then I've got 10 squares is 2.5. So each 1 square is 0.25. So each 2 squares is 0.5. So I'll just check that makes sense. 0.5, 1, 1.5, 2, 2.5, and so on. Okay, so I'm checking that. So 0.5 is here. And if I do it in pencil, I can rub it out if I make a mistake. 0.35, so halfway in between, is 2.5, so that's easy to plot. It's there. 0.4 is 1.5, so I'm spotting something strange here. Okay, so that's 0.5, 1, 1.5 is this point here. Then 0.45, I'm getting 2, so that is here. So I can check that. Half, 1, 1.5, 2. 0.5 is 4.5, so that's half down from 5, so that should be there. Then 0.55 is 9, so that's 4 squares down from the 10. So 4, that's there. And I can mark on that this is 7.5, and I can mark on this is 12.5. Then the 0.61 is right at the top, and we get that there. So correctly plotting all those points, sensible scale, labelled axes, not labelled yet. I haven't labelled this one yet. So final checks you should be doing. Look back at your graph. Do I have labels on both axes? Have I plotted my point? Are the scales sensible? Yes, 3 marks. A little bit of time, but it's worth spending that time. One of the points is anomalous. Well, as I was plotting it, it became clear that this point is the anomalous one. So there's 3 marks to the graph, 1 mark for that, then a curve of best fit. Now the curve of best fit should ignore the anomalous point, so I shouldn't include that. And then I'm turning the page around to help me draw a smooth curve. And to be honest, for me, I'm doing this effectively backhand. Forehand would be this way, but that doesn't really work with how my shoulder works. And you do get better with practice. Not essential, this is brilliant. You do get better with practice, but it should be a smooth curve, something like that. So a smooth curve where you're trying to have a reasonably similar numbers above the line as below the line. Okay, so nice smooth curve, 5 marks for that. This question, a reason why line graph, it's almost always the same answer. It's because your variables are continuous. So both variables are continuous. That's only 1 mark, and that's dealt with that. Formula linking voltage, current, resistance. So you can use the words voltage equals current times resistance, or you can use the standard symbols, but the standard symbols are capital V, capital I, make it clear it's an I, put bars on it, multiplied by capital R. So they're the standard symbols. Use your own symbols, you won't get the marks unless you've got the words to show it. Final part of this, 4-mark question for a calculation. Things to watch out for. We've just written the equation, so that's the equation we're going to be using. So any current larger than 15 milliamps will permanently damage the LED.